Hi, welcome back to Mathematical Maths. So today we're going to do the Taylor series for e to the x and e to the ax. Now this was from 2 videos ago with the Taylor series. This is like a continuation of that, of the Taylor for sine and cosine. So let's get started. So we'll first do e to the x and then work our way to e to the x. But this is very easy because any of you who have done calculus before know that the derivative of e to the x is just 1 when it's to the power of is just itself, and when x we go around to point 0, it's just raised to the power of 0, that's just 1. So we'll start off with the derivatives. We have y equals ex, this is first derivative, y equals ex, second derivative, y equals ex, third derivative y, or we'll go nth derivative, y equals ex. So because we're doing the Taylor series, Maclaurin part, which is this, from n equals 0 to infinity, around the function's nth derivative around point 0, multiplied by the x to the power of n, multiplied by n factorial. So because we're going around the point 0, we're going to set all of these x values equal to 0. So we're going to go here, okay, e to the 0 equals 1. E to the 0, 1, 1, 1. So now all we have to do is get our polynomial, which is a0 plus x a1 plus x squared a2 plus x cubed a3 plus x to the 4th a4 plus ... Right, so now we'll start looking at these values. So a1, we say 1 equals a0 because this is just the initial equation, and this will help us get our y location, and that's just going to be 1. Now we do the next part. 1 equals a, that's 1 again. Then we bring 2 down in front, so that's 2 factorial multiplied by a to the second, or a2 equals 1, 1 over 2 factorial. So x squared divided by 2 factorial. Then we go to the next one, plus, bring the 3 down, 1 equals 3 factorial multiplied by a to the third. That's going to be x to the third over 3 factorial. And you can probably see what's happening here. It just repeats this pattern of increments of 1. So if we were to write a Taylor for this, or a sum, we're going to have a sum from n equals 0 to infinity. So since it's not going from positive to negative, we don't have to have that minus 1, but we do need to have a look at the factorials. So we can say this is the same as 1 factorial, and this is the same as 0 factorial. So since it's going from 0, we know that it's going to be n factorial, because it goes 0, 1, 2, 3, 4. So it's just going up in increments of 1, and our sum function does that already. And then it's the exact same with the power, x to the power of n, because it goes 0, 1, 2, 3, 4. So that is the equation for the Taylor series expansion for e to the x. So as this term here approaches infinity, that's what the Taylor series value is. So now we're going to do e to the x, and I'll be back in 1 second. So now we're going to do the e to the ax and find the Taylor for that. So if we start writing down the derivatives, so the equation is e to the ax. Now when we take the derivative, remember when you have e to the or e of anything, the exponential part stays exactly the same, but you're going to bring that first coefficient down to the front. So it's a multiplied by e ax. Second derivative, a squared e ax. Third derivative, excuse me, third derivative is going to be ax. So as you can see, the a power just represents the derivative number. So when we start writing the Taylor series for this, first of all, we can put in the x coordinates and see what's happening here. Because we know we're going around the point 0, that's just going to be 0 multiplied by a, which is 0, and anything to the power of 0 is 1. Then this part here, we have 0 multiplied by a, 1 again, and that's multiplied by a. Here, exact same thing, this turns to 1, then we're left with a squared. This part here, second one, that's left with a cubed. So now we know that it's just following this pattern. A to the first, a to the second, a to the third, and we can even write this first term as a to the 0th. So this continues to the nth derivative, that's a to the n multiplied by eax, now equal a to the nth. And that's the derivative number, not the 1, 2, 3, 4. It's the first derivative, second derivative, third derivative, nth derivative. So when we write the sum for this, it's going to be the sum from n equals 0 to infinity. And because we're looking at the exact same function, we still need our x to the power of n. And that's part of the Taylor series. And that's where we get the polynomial terms. We still have the factorials. Now, what happens here is we have all these values here. So a to the power of 1, a to the power of 2, a to the power of 3, a to the power of n. Now, when we have our polynomial, it's going to be a0 plus x a1 plus x squared a2 plus x cubed a3. So now we're just going to plug in these terms. We know this simplifies to 1. Then we have, really quickly, don't confuse these a's. These are just different things. So like, we'll call these ones b's for now, so you don't get confused, because they're not at all related, apart from the fact that this represents the derivative of, these terms represent these derivatives. So what happens, we start off with 1, that's going to be 1. Plus, and then we have b, 1 factorial comes down, b equals a. So we're going to have a multiplied by x divided by 1 factorial, or just 1. And then we have this next part, a squared equals 2 factorial, b2. Rearrange, it's going to be a squared divided by 2 factorial, and multiplied by x squared. So you can probably see what's going on there. It's just going to repeat this pattern. 3 factorial, a to the third, x to the third, plus dot dot dot, plus n factorial divided by a n x to the nth. And that is what our Taylor series is going to be. So we're going to have a to the n here, we're going to have n factorial. And this, as it approaches infinity, is going to equal e to the ax.